Hey everybody, today we are going to switch from categorical data to quantitative data, data that can be measured, and we're going to talk about describing the data and ways to display it. We will create different data displays for quantitative data together. For today, we are going to learn how to describe that data. So 3 different popular ways that we will display our quantitative data are through histograms, stem and leaf plots, and dot plots. And in all 3 of these types of displays, we get shapes to our data. And what we need to learn is how to describe those shapes because they're important. You can see a histogram looks like a bar chart, but what's really important is that any gaps that exist in a histogram need to be intentional. So in a bar chart, we just sort of separate all the bars in equal distance. Here, the location of the bar represents a measurement, so we need to be careful with that. We will talk about constructing these, like I said, again in class. But for right now, this is just a quick, hey, this is how we can display our quantitative data. And you can see they all sort of give the same idea, but we'll talk more about those together. For now, we want to learn how to describe the distributions or the quantitative data displays. And so we have this mnemonic, and it's a good way to remember what things we should say about a quantitative distribution. We want to talk about shape, any unusual characteristics, the center of the data, and how spread out it is. And so when we talk about shape, there are a few different shapes that we can see. And we need to make sure that we have appropriate word choice. So when all of the bars in a histogram or all of the stems in a stem and leaf plot, or the leaves I should say, and in a dot plot when all the bars that form by putting dots on a dot plot, when they're all almost the same, so you can see in this first one, all of those bars in our histogram, they're not exactly the same, but they're almost the same. And so what we would call this is, and this word approximately is important, it would be approximately uniform. So a uniform distribution is when all of the bars or all of the categories, or not, I shouldn't say categories, all of the, we call them bins, where we put the counts in there. When they're all the same, we call that uniform. So that was approximately uniform. You can see the word here, I think, on this one. We are going to say that this thing is approximately symmetric. If it were exactly symmetric, we would say it was symmetric, but this is approximately symmetric. If you look at this line in the middle, it's pretty close on both sides. It's not exact. Sometimes I like to put a little curve on top just to give myself a quick view of it. It's approximately symmetric. And I like to do these curves just so I can get an idea of, just give myself a real simple idea of what the distribution looks like. So these two distributions, they are both what we call skewed. Skewed quantitative data distributions typically, or not typically, they will have like a group of a lot of data points together, and then we have this sort of thing where it tails off. It tails off here. These bars, as we get closer to 40,000, get shorter and shorter. We have here where it tails off this way. And so we want to make sure that we're intentional about how we say how these are skewed, and the skewness follows the tail of the distribution. So this distribution on the left, the tail is on the left, and so we would call this left skewed. This one is on the right, the tail is going to the right, and so we would call it right skewed. So when describing a quantitative data display, we want to say what shape it is. We want to identify whether it's approximately uniform, approximately symmetric, left skewed, or right skewed. When we talk about unusual characteristics, we'll look at a few things. We'll look at potential outliers. Outliers are data points that are really far from the rest of them. So in this picture, that is a potential outlier. We have a way to calculate whether or not it is an outlier, which we'll talk about later, but right now we'll say it's a potential outlier. We want to talk about any gaps in the data. So here we have a gap, a big gap between around 30,000 or 3,000 and 7,000. We would want to talk about any clusters. So sometimes we will get a group of data that is on one side, and then we'll have some sort of gap maybe, and we'll get some other significant group over on another side, and so we could call those clusters. So we're looking for potential outliers, any major gaps, and if our data is clustered in some way or grouped in some sort of way. We'd also want to talk about the center of our data. The center in this class is typically described as a mean or an average or a median. And so if we have data that is approximately symmetric, the best measure of our center is going to be the mean. Remember, for a population, it's that Greek letter mu. For a sample, it's x bar. So if we have a symmetric or approximately symmetric distribution, we are going to want to refer to the center by referring to the mean of that distribution. And we might approximate the mean if we don't have all the data points. So the mean here is approximately 0. If we have skewed data, we want to use the median, which is quite literally the middle value. You should have some experience with that. And the reason we want to use the median to describe the center in its skewed data is because data points like this one over here that are potential outliers are really going to affect the mean. When we calculate the mean, we add up all the data points. And so when we add a data point that is really unusual compared to all the rest of them, it's going to really manipulate the mean. And what happens is the mean of this distribution is going to get pulled towards that outlier. So if we take that outlier out, our mean would be much smaller than if we put it in. And so the median is not really affected by the outlier because the median is just the middle number. And so the outlier is not going to affect where the median is located. So it gives us a better idea of where the middle of the data is, which is probably going to be somewhere in here. And the last thing we want to talk about is how spread out is our data. It's okay to know a center, an average, a mean, a median, but we want to know how spread out is it. And so when we're talking about symmetric distributions, again, you can see I'm using just the same pictures. We would want to talk about the standard deviation. And I believe we calculated that the other day. For a population, it's sigma, and for a sample, it's S. If you look on your calculator, when we do one variable statistics, it's that S sub X. When we look at a skewed data set, we want to look at one of two measures of spread. We can look at the range, which is quite literally the max minus the min. So the largest value minus the smallest value. Or we can look at this thing called the IQR, the interquartile range. And that tells us how spread out the middle 50% of our data is. We will calculate IQR soon and talk more about that. But just know that when we're trying to describe the spread of our data, if it's a skewed distribution, we don't want to use the standard deviation. Just like with the mean, standard deviation uses every data point, and if we have a data point that is far unusual, like a potential outlier from the rest of the data, it's really going to affect our standard deviation. And so instead, we'll talk about the range, or the interquartile range, which is how spread out is the middle 50% of the data. So I want you to pause here and see if you can hit these key elements. And I will say that when I ask you to describe a distribution, what I'm asking you to is write to me a paragraph about this distribution. You can bullet point and use this mnemonic to sort of organize your thoughts if you want to, or you can just write it down to make sure that when you're writing an answer, you hit all 4 points. But you should always be writing to me a proper set of sentences. So take a minute, look at this distribution, and see what you come up with. So when I look at this thing, I would say that this distribution, I guess we didn't say this, you could say that it's slightly skewed to the right. That little bump there makes it kind of weird. Another way we can call it, so if you didn't get this because we didn't call it out together, we could call it bimodal. We sort of have two clusters that have the tallest bar. You could call it skewed right. And again, I'm just documenting these, but you should write them out. I would say that we have two clusters. We're going to look for the median sugar percentage, so we should say something about the center being the median, which I would say is approximately, we could say approximately 28%. And then since we have this non-symmetric distribution, let's talk about the range. Since we haven't really talked about the interquartile range, we can say that the sugar percentage ranges from 0 to about 64%. And you would write this in a paragraph. I know I'm not showing a great example, but trying not to hold you up too much on this video. And we always, always, always want to include the context of the problem when we're describing the distribution. This is a histogram displaying sugar content. So when we write about when we describe the distribution, we always want to include like the distribution of sugar content. We want to include any units, percentages, when we're talking about center and spread. So I'm going to have some problems for you based on this one. So be sure to watch to the end, ask questions if you need some help, and good luck. We're describing this distribution, so make sure you answer the questions based on this distribution.